This generated video displays a photorealistic glass of water suspended midair, with the liquid flowing upward against gravity in an otherwise normal room. Visually, the rendering is highly detailed, but physically, it is a complete failure state. The root cause of this error lies in how the underlying system operates. Standard autoregressive models function as statistical pattern matchers. They process massive datasets to guess the next logical pixel in a sequence, completely detached from the laws of physics. When an AI attempts to predict every fine-grained, continuous change in an environment, it is forced to compute the average of all possible futures. The sheer volume of high-dimensional noise overwhelms the system, resulting in severe physical hallucinations. A true physical simulator operates under a strict set of constraints. It requires a causal, grounded world model that understands gravity, fluid dynamics, and object permanence, rather than relying on statistical probabilities. The Cesare Protocol abandons pixel reconstruction entirely. Instead of attempting to guess the visual appearance of a scene, it maps the underlying rules governing the environment. Without an internal engine of causal mechanics, AI outputs cannot be trusted for real-world application. We require a shift toward deterministic truth algorithms that verify reality instead of approximating it. Project VITA provides the framework to replace statistical hallucination with physical verification. It establishes a verifiable digital nervous system that tests the empirical reality of digital media. This PhD-level architecture is actively migrating out of the research lab. It is being deployed directly to high school students to combat misinformation at the community level. Through the iVirtue's Bridging Tomorrow curriculum, these advanced concepts are integrated into the iGentix AI classroom. The curriculum empowers entry-level students to architect their own verifiable truth systems. They learn to treat artificial intelligence as a collaborative tool that requires rigorous auditing. We are going to deconstruct the mathematics behind the VITAVQ framework, examining how complex data validation is operationalized for student use. True digital fluency requires understanding the mathematical foundation of a deepfake, equipping users to prove a manipulation rather than simply suspecting it. Traditional generative models fail because they dedicate massive computing power to reconstructing ephemeral details, like the flickering of a shadow or shifting lighting, which are inherently unpredictable over time. The structural solution utilized by Nature AI is the Image Joint Embedding Predictive Architecture, or iJPA. It begins by fragmenting a high-resolution image into distinct grid patches, explicitly discarding the raw RGB data. The encoder maps these inputs into an abstract latent manifold. The image converts into a network of high-dimensional mathematical vectors connected by rigid geometric lines. This latent space intentionally ignores visual noise. It preserves only the causal rules and the structural relationships between objects, filtering out the irrelevant data that confuses standard models. Once mapped, the model predicts the future state of the environment entirely within this abstract mathematical space, maintaining a clear, objective-oriented plan. If an impossible physical event occurs in the prediction, the system registers a massive spike in prediction error, instantly flagging the anomaly. This method is highly parameter efficient. It bypasses the massive computational overhead required by brute force pixel generation, allowing it to run smoothly on local hardware. By transitioning to an abstract representation space, the AI stops guessing appearances. It begins understanding structural physics. The Visual Integrity Truth Algorithm, VITAVQ, acts as the ecosystem's cryptographic gateway. It serves as an epistemic filter at the extreme edge of the network. VITAVQ bypasses common deepfake artifacts like blurry pixels or distorted hands. It runs a rigorous test on the underlying physical truth of the scene. This is the first step in a forensic process called specular light mapping. A close-up wireframe model of two human eyes highlights distinct white corneal catchlights on the surface. By tracing inverse 3D light rays backward from those catchlights, the algorithm mathematically maps the implied environmental light source that created the reflection. In a generative hallucination, the model rarely computes consistent 3D lighting. The ray tracing fails to converge, triggering a zero veracity quotient. VITAVQ also tests for biological structural tension. It verifies the precise biomechanics of a genuine divergent gaze, measuring how muscles and eyelids interact. exposing models that hallucinate perfect symmetry where it shouldn't exist. These specific tests allow the system to differentiate between aleatoric uncertainty, which is natural environmental noise, and epistemic uncertainty, which exposes the model's sheer ignorance of physical laws. A synthetic image might easily deceive human vision, but it mathematically collapses when VITAVQ forces its internal geometry to obey the laws of physics. The ultimate function of the Cesare Protocol is to operate as a neurosymbolic code world model, binding neural networks to strict deterministic rules. This architecture relies on retrodiction, also known as VITAVQR. It is the engine's ability to calculate the past, tracing the continuous vector field of macrophysics backward from a current event. A flowchart maps a current state vector, xt, backward along a strict pathway. The model solves for xt-1, calculating the exact preceding state to ensure a continuous causal history exists. This mechanism, utilizing reverse flow matching, acts as a forensic sandbox for deepfake detection, testing whether the geometry of a scene permits a logical past. When VITAVQR attempts to retrodict an AI-generated image that has no actual physical origin, the calculation breaks. The system returns a massive prediction error, proving that no valid mathematical origin exists. This process creates a mathematically defensible perimeter around the training data. Maliciously injected data is filtered out, ensuring the world model remains uncontaminated. If a visual scene cannot be successfully reverse-engineered through known physics, it is scientifically proven to be an artificial anomaly. A mathematically perfect physics engine is completely useless in the field if its output remains an uninterpretable black box to the operator. A sleek digital dashboard UI shows a dense grid of complex mathematical vectors, transforming into a clear, actionable English diagnostic sentence. This translation layer is called Newton's CLIL. This tool leverages mechanistic interpretability. It decodes the high-dimensional latent embeddings generated by the physics engine and converts them into accessible semantic directives. This enables the crucial human-in-the-loop requirement. Operators manually validate the semantic directives on the ground, ensuring the algorithmic output remains strictly tied to real-world conditions. This workflow prevents the AI from dictating commands from behind a screen. The operator acts as the ultimate truth checker, using the model to amplify their own agency and decision-making. Transparency in AI architecture is a mandatory structural requirement for safe, reliable deployment in complex physical environments. These concepts are actively tested inside the iGentix AI Generative Semantic Workspace, creating an interactive classroom environment for students. Students use this dashboard to move far beyond monolithic, single-prompt AI interactions. They learn to orchestrate an assembly line of specialized interacting agents. A data packet begins at the architect node, pulls required empirical constraints from a librarian API node, and terminates at a validator checkpoint for cross-referencing against external physics. This modular structure decomposes complex problems into discrete tasks, allowing high school students to execute advanced veracity checks without needing a PhD in machine learning. Moving through a modern STEM laboratory represents the core iVirtue mission, bridging the digital divide by bringing rigorous AI literacy to underserved communities. By integrating VITAVQ toolkits directly into education, the next generation moves from passive consumers of synthetic media to active, verifiable auditors of physical reality.